So we got this pool, and maybe we're thinking about, the cost of filling up this pool. The units are usually given in like gallons on our water bills, I think. Maybe it's liters, I don't know. But either way, we want to know the volume of this pool. Okay. So in this question, the units they're asking for is how many liters would it take to fill this pool? And the dimensions of this pool say it's 160 by 30 centimeters. And then the slash is their way of saying, hey, the other way of saying that is 63 inches by 12 inches. So these are approximately equivalent to each other, but they're not exactly equivalent to each other. Okay. So they give us two different units. They give us centimeters and they give us inches. And since our goal is to calculate liters, liters are a metric unit. So we'll want to use this version. Okay. You could calculate the volume using inches, but since our goal is liters, liters is metric and centimeters are metric. So that's what we want to use. Okay. So it's a right cylinder. So as we've studied before in math, the volume of a right cylinder is the area of the base. So it's pi r squared times the height. Okay, and then the dimensions, I think this is all the way across, so it's 160 meters all the way across, 160 centimeters, whoa, 160 meters would be huge. And then this dimension 30 would be how deep it is. So it's 30 for a height. So we got pi, and then the radius, it's 160 all the way across the pool. So the radius is half of the diameter. So that'd be 80 for the radius here. 80 squared, that's 80 centimeters squared times 30 centimeters. So you got centimeters times another centimeter, so the units here are centimeters cubed. Okay? Because 80 is centimeters, and then 80 times itself, that's centimeters times centimeters, and then times a third centimeters gives us cubed centimeters. And then we can just use a decimal approximation here. 80 squared times 3.1416 times 30. So this is how many cubed centimeters that this thing is going to take up. So we need to convert this to liters, and we have this conversion factor that can help us. We've got 603,187.2 cubic centimeters, and we're told there's 0.01 cubic meters in 1 liter. So we'd like to first convert this to cubic meters, okay? And that's where we can use a conversion factor. We can multiply this by, look, if there's 100 centimeters. Oh, here, we want that in the denominator, though, to make the centimeters units cancel out. There's 100 centimeters for 1 meter, right? But we're trying to make cubic centimeters cancel out. Okay, so this isn't cubed yet. We have to cube this entire thing. So we get 603,187.2 cubic centimeters. I've got to cube the top and the bottom so that I have cubed units. So now we'll have cubic meters. And then on bottom, you got to do 100 cubed. So 100 times itself 3 times. So that's 1,000,000 centimeters cubed. And so now we can have our units cross cancel. Oops, that's not equals, that's times. Sorry, we're multiplying those two. So the centimeters cross cancel. Now we're in terms of cubic meters. We've just got to do 603,187.2 cubic meters over 1,000,000. And then when you divide those two, so 603,187 divided by 1,000,000, you got 0.6, we'll just say 0.6. This is 0.6 cubic meters to fill up this pool. Okay, which might not seem like a lot, but if you've ever looked at a cubic meter, it's pretty big. And this pool isn't very big. This isn't like a standard pool. Look, the dog is taking up, what, a fifth of the pool? So there's a lot, those are small kids. Okay, so the pool is 0.6 cubic meters. We're almost done. There's 0.001 cubic meters in 1 liter. So we want liters in the top. We want our final units to be liters. But I'm going to multiply by a conversion factor, 0.001 cubic meters. So cubic meters in 1 liter. This is our conversion factor because we're told both those things are equivalent. And I put cubic meters in the bottom to make sure that those cross cancel with each other. So I got 0.6 liters over 0.001, and if you divide those two, that's 600 liters. So it'll take 600 liters to fill up that pool.